For this example, what we're going to do is look at this theta degree here as a rotation. So it's a positive rotation heading in the direction, well, what is that going to be? 90, 180, 270, plus another 45. So I'm guessing that that's probably about 310 degrees-ish. All right, so what we're going to do is we're going to find, more or less, we're looking for when theta equals 315 degrees, what does sine, cosine, and tangent look like? So there's our to-do list. We need to find sine, cosine, and tangent. Well, we're going to set this up exactly like we did with that first example. And in this case, well, sine of theta is going to equal, from this area right here, the opposite over the hypotenuse. And let's give ourselves a reminder. We got so, ca, and then toa. Okay, so opposite over hypotenuse, and I know that my opposite is going to be, well, this length right over here, and that's going to be -5. So there's a -5 right there. And then over hypotenuse. Well, the hypotenuse we don't really know. Let's call that length r. And the reason that we call it r is because if I was to pull a circle right here, that r is the radius of the circle, and it stays consistent as theta changes. So r will always be positive. Let's write that down just so we can be doubly sure. R is always positive number. U-S-I-T-I-V. I'm sure, I'm positive, I'm thinking really good vibes about that. I'm dead sure. Okay, so there we go. So let's Control Z a couple times until we can get rid of that circle again. Well, we need to solve for r. So I'm going to do the old Pythagorean theorems. I'm going to do 4 squared plus -5 squared, and that's going to give me 16 plus 25, 41. Okay, and this is c squared, or in the case of Pythagorean theorem, or we could also call it r squared. So we can say that 41 equals r squared. That means that r is going to equal root 41. Okay, cool. 41 square root, and that's that length for r. Right, root 41 right here too. But the problem is that I have I've got a radical in the denominator, so I'm going to do root 41 over root 41. This is called rationalizing the denominator. And then my final solution, let's give it a new color, bright blue. It's going to be -5 and then square root of 41 all over 41. Okay, cosine. Cosine of theta. Cosine of theta equals, this is going to be adjacent over hypotenuse. So that's going to be, let's see, let's come in and erase these arrows a little bit. So I'm going to do adjacent from this angle, so that's that length right there, which is going to be 4, +4 over root 41. And again, we're going to have to rationalize that denominator, so there's 41, root 41, and we're left with 4 root 41 over 41. Okay, and then last but not least is tangent of theta. And the tangent of theta is going to be opposite over adjacent. So there's my opposite length right over here. And then adjacent, so that's going to be -5 over 4. Great, so that's the first part. Now here's the next part. Use reciprocals to find cosecant, secant, and cotangent. Now remember that cosecant, let's see, let's get another layer here. Cosecant, there we go. Cosecant is directly tied in with sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So knowing that, it's pretty easy to do the math. I'm going to write first cosecant of theta is just going to be the negative inverse of -5 root 41 over 41. So, I'm sorry, not negative inverse, the inverse. 41 over -5 root 41. Well, shoot. But what this means is that we actually have to rationalize the denominator. So we have to multiply by root 41 all over again. What would happen, though, is if instead of working with this value right here, why don't I just go back to the very beginning and use this value, because all I did was multiply it more or less times 1. And so I'm going to rewrite this instead as root 41 over negative 5. There's my cosecant of theta. Now, secant of theta is going to be the same thing, and I can rewrite this as root 41 over 4. And then cotangent of theta is just flipping the very beginning. You can't really see it, it's kind of hidden under there, but it is going to now be 4 over 5. All right, there you go.